In this video, we're going to look at how to use factors in R. Now, a factor is a special form of vector that's used with categorical variables. So let me read in some data here containing some categorical variables. So the data I'm going to use is the one that I used in the video on importing from a CSV file. So using the standard read.csv command here, I can read that into a data frame. If we look at the data, as we can see, it contains two categorical variables, gender and site, and one numeric variable, which is usage in terms of hours per week, and there are 20 cases. So this is just a simple file I created for illustration purposes. Now let's look at the structure of this data frame. And as we saw in the video on importing data, when you import data containing categorical variables into R, by default it turns those categorical variables into factors. And a factor is a vector with levels. That is, the levels are the actual values, in this case in gender F and M, but the vector in effect contains numbers, because by converting it into a factor, it's coded these values, these levels. So a 2 here for female and a 1 for male. And on this one with 3 levels, Facebook, Pinterest and Twitter, again, those are being coded. So the big advantage of this is that it pre-codes these categorical variables for you when you import the data, so you don't have to do it yourself. This means that you can then use those factors with the various commands. Now, probably the most important function command to use with factors is the table function. This creates frequency tables and crosstabulations, and it returns what's called a table object, which is simply a special form of vector or a matrix, as we'll see. So here I'm going to use the table function, and I'm using as the argument this gender variable, which is now a factor. So in other words, you have to give table function a factor as its main argument. There are obviously other options which will be available here. You can find those in the help file if you look at this. As you can see, if I pause over that, you can see the pop-up tells me some of the other things. Now, of course, these all have default values which you normally don't need to change. So in this case, all I'm putting in is the factor gender. So if I run that, what I get is now a table object, which in this case is a vector, stored in this variable. Let me print it out. And what it's returned, of course, is the frequency distribution of this variable. In these 20 cases here, 9 are female and 11 are male. It's returned it effectively as a vector with names. We've seen before that you can actually have names of the elements in a vector, and therefore to access the elements you use the standard vector notation here, which of course involves putting the index in square brackets. So if I run this command, it's going to return the 9. Now, the other advantage of creating a table object using the table function is that you can then plot that table, that frequency table or the cross-tabulation, using the Barplot command. Now, we've seen before, of course, how to use the generic plot command for plotting time series and other data. When it comes to plotting a table, then you have this Barplot command, which will, as the name implies, plot a bar chart. So here I'm going to use Barplot, then I'm going to give as the argument this table that I've created, this table object, which remember is just a single is a vector because it's just a frequency distribution. Again, I'm not putting any other graphical parameters here to make it look nicer. We'll look at that later. So this is just to show what happens. So if I run this, as you can see, we get a simple bar chart of those two values, 9 females, 11 males. As I say, not particularly nice looking because I haven't included any of the additional parameters that we looked at in the videos on plotting. I'll do that later on. Okay, so that's how we can use the table function just with one factor to create a frequency table. If I use it with two, then of course I'll get a cross tabulation. I'll get a breakdown of the values by the two variables. So here I'm going to use the table function and I'm going to input gender and site. Notice of course that because this is a data frame, we can use the list style here using the $sign, which is a nice easy way of doing it rather than the matrix style. So notice that you put them separated by commas. So this should return a cross tabulation of these two variables. So let's print it out. And that's what we get. The two variables, gender and site, have been cross-tabulated to show the number of cases in each cell. So in other words, within those 20 cases, 3 of them were female using Facebook, 2 were male using Pinterest, and so on. If you look back at the original data, you'll be able to confirm those values. I won't do it here. And of course this will add up to 20 because there's 20 cases. Now you might want not the actual value, the actual number in each of these cells. You might want them as proportions or percentages. What proportion of the 20 cases were Facebook users and female? The command for doing that is prop.table, and that operates on a table object. So here I'm going to take the values in this table object here, cross.tab, and convert them into proportions, like that. So these are proportions, 0.15 or 15% of course, of these 20 cases were Facebook users and female, 25% were male and on Twitter, and so on. Of course I could have done this in one command. Remember we've seen before that you can easily nest various R functions. So rather than doing this separately here, I could have put prop.table, and then in brackets I could have put this table function. So that would have given me this in one go rather than in 2 steps. Now the other command that is often useful with table objects is add margins. That, as the name implies, will add the marginal sums. It will find the row sums and the column sums and add them onto the table. So what I'm doing here is I'm creating another table object, cross.tab.1, which adds the total rows, the sum rows, the sum columns, sum of the rows rather than the sum of the columns, onto this table. So again, you have to feed it a table object here. So if I print that out, that's, as you can see, we now have a table object which also has the row totals and the column totals. Now, as we saw up here, if you want to print out a table object, a frequency table or a cross tabulation, use this barplot command, which takes as its main argument a table object. In this case I'm going to, here I printed out the frequency distribution of gender. Here I want to print out this cross tabulation here that I created, cross.tab. So let me run that command just with that table object as the only argument. And what we get, as you see in this case, is a stacked bar where the values of male and female have been stacked on top of each other. So as you can see here, there were 3, if you look at Facebook, 3 female and then another 4 male, which gives me the 7 altogether. Now that may be what you want, but it's probably the case that you'd like to see these separately, side by side. To do that, you use the beside equals true option. So putting beside equals true in here as an additional argument, we can get that, which is probably more what you want. This time the male and female are separated. Again, of course, this as it stands is okay, but it could be, we need, of course, additional elements. We need a title and perhaps a label here and so on. Well, we've seen how to do that, of course, in the videos on plotting. So for the details of that, you can have a look at those videos. Here I'm going to include some of those parameters that we've seen before. Main to give us the title, ylab to give me a y-axis label, the colors here command to color these bars, beside equals true, which we've just used, so I'll get it like this. The other thing here, however, which is different in the videos where I used the plot command, we saw there that you added a legend separately by using the legend command after you'd done the main plot. With the barplot command, you can actually include the legend within the barplot command itself by putting legend.text equals and then a character vector with the names of the two variables. So you don't need to do it afterwards here with a separate command. You can do it within the barplot command. So if I run this, you'll see we get a much nicer looking graph. Same data as before, of course, but now as you can see it's much better. We've got a title, we've got a proper label here, we've got a legend, we've got different colors. That's a much better graph. Okay, the final thing I want to look at on factors and categorical variables is how you can apply functions to the numeric variable in your dataset, one of the numeric variables, which you can then break down according to the categorical variables. And to do that, you use a function called tapply. Now we've seen how to use the apply without the t, the apply function, when dealing with matrices. Here, when we are dealing with a table object or categorical variables, we use a slightly different one called tapply. So what I'm doing here is I'm going to find it has the syntax very similar to the apply function, but it's slightly different and it's specific to these categorical variables. So what I'm going to do here is to find the mean of the usage hours variable. That, of course, is a numeric variable, so I can find the mean of the values, but I don't want just the mean of the whole values on their own. I want to break that down into the mean hours on Facebook and the mean hours on Twitter and so on, and also break that down also by gender. So in other words, I'm wanting to find the average number of hours that men use per week on Twitter, the average hours that women are on the Facebook site per week, and so on. So in other words, I'm finding the mean, which is then broken down according to gender and site usage. So to do that, I use the tapply function. First of all, you specify the numeric variable that you want to analyze, then a comma, and then using the list notation, you list the two factor variables that you want to analyze it by, and then another comma, and then the actual thing you want to do, in this case find the mean. So very similar syntax to the apply function, but not quite the same, and you need to make sure you use a list notation here. Obviously I'm using the mean here. You could put some other function in, another built-in function or your own function. So let me run this command which I'm storing in this means by gender by site variable. If I now print that out, what we can see is it's done exactly what I wanted. It's found the mean number of hours of usage per week by women on Facebook, by men on Facebook, women on Pinterest, and so on. So it's found the mean of those particular values which apply to that particular cell. Again, if you go back to the original data and check that, you'll find that these values are correct. So in other words, on average, women who were on Facebook were on for 48 hours per week. Men who were on Pinterest were on 19 hours per week, and so on. Now notice that's returned a matrix here, although it's effectively a table object, although it's actually called a matrix here. That means, of course, you can access individual values using matrix notation, but since it's also effectively a table object, I can use the barplot command, as I did up here, to print out this table, just like I printed out this one. And again, so it's the same syntax that I used up here, barplot, then the name of the table object, or the matrix in this case, and then of course I can add some additional parameters to make it look nicer. The only one here that is different from above is I've used the ylim option, which we saw in the video on graphics, to specify the y-axis scale. So running that, we get a nice bar chart broken down in by site and by gender, showing average or mean weekly hours of social media usage with a nice legend. Okay, so that shows you how you can use factors and tables in R to analyze categorical data.